Welcome to the tutorial on how to visualize function transformations. I'm here in the software Microsoft Mathematics. I've only highlighted the window we'll be working within. You're going to want to go to the Graphing tab. So what we're going to do is we're going to take the function f of x equals x squared, and we're going to graph some of the points on it, some of the coordinates, and then we're going to see how those particular coordinates are transformed by the transformation f of the quantity x minus 4. So we're going to subtract 4 from all the x values and then see what happens. So I want you to use the tab that says Data Sets, not the tab where you type in the equation. We will do that later. Under Data Sets, you can go ahead and click on the table. I've already filled in, populated the x values, -6 to +6. Next thing we're going to do is, as you can see, I've already filled in the outputs. If we squared each of them, here's the outputs we would get. And then if you click graph, it'll go ahead and graph those coordinates for you. This is our original function. Now let's see what happens when I take each coordinate and I apply the transformation, decrease the x values by 4. So I go back to my data sets and I open a second data set. I can click on the table here. I can click on the table here, use the same x values, -6 all the way to +6. And now I'm going to apply the transformation. So for example, the first input is -6. The transformation says to take my x value and decrease it by 4. So -6 now becomes -10. So now I have -10 as my new input, my new x. I square that and I get 100. And I keep doing this, and I'm going to notice at a certain point, all of a sudden, the output values start to look familiar. When I get down to -2 for my x value, my output is 36. That showed up in our original function, an output of 36. Again, when I have -1 as my x value, my output is 25. The next output, when x is 0, I get 16. These have already shown up in the original function. So you click OK, and the graph shows up in green for our transformation. Now, in order to highlight what happened to each coordinate and which point it transformed into, I went ahead and I saved the graph as a picture. And I'm going to open it in the paint file. And actually, let me see here. I'm going to open it. So there it is in the as a JPEG, and then I'm going to open it with the paint program, and let's see if I can get this in the window where you can see. Okay. So let's go ahead and take a look at what happened with each individual point. I'm going to get an arrow. Ready, here we go. So let's take a look at the input of -6. Normally when we square that, our output would be at 36. However, with the transformation, when I put -6 into my function, the output is much higher than 36. It's actually way up here at 100. What happened is that the transformation told the x value, -6, to go backwards 4, 1, 2, 3, 4, and steal that output and reassign it. So backwards 4 is at -10. So that 100 that belonged to -10 is now reassigned to -6. That happened here again at -5. Normally -5 squared would get you an output of 25. The transformation said, okay, if you're an x value -5, you go backwards 4, 1, 2, 3, 4, and you take the output value that's normally there and you reassign it to yourself. So -5 now gets 81, which normally is -9 squared, but we reassigned the value here. And that keeps happening, and then I'll go ahead and show you how once we reach our blue dots, so -7 times -7 is 49. That gets reassigned though to the x value of -4. That was -8 times -8 up here at 64. This is -7 right here. It gets reassigned to the -3 x coordinate. Now we get into where this blue dot gets transferred over here. So when my x value is -2, normally I would square it and get +4. The transformation had us go backwards 4, 1, 2, 3, 4, and take the y value that's normally assigned here, and it's reassigning it to the -2 x value. So I get -2, +36 as my output. It's reassigning. So notice how all my outputs are shifting to the right. I'm going backwards, and then I'm taking them and reassigning them. Same here, if the input is -1, I need to go backwards 4 x values, and then I need to take the output and reassign it. And this continues to happen. It's going to get a little harder to see, so I'm going to make the lines smaller, and I'm even going to change the color to red just so we can see a little better. So here again, got reassigned. This one got reassigned here, the 0 x coordinate. Got reassigned. So normally it's 0 times 0, but we went backwards. Let me make sure this is matching up. Hold on. We went backwards 4, 1, 2, 3, 4. Oh, the transformation. Yep. Sorry, I confused myself there. So the green dot is at +4, and it went backwards 4 spaces. 1, 2, 3, 4, and it took the output that normally belonged here and it reassigned it. This green dot is at +5. Normally 5 times 5 would be 25. There it is. But instead of having a value of 5 get squared for 25, the value of 5 first decreased by 4, and then it reassigned that particular output to itself. Same here. If my variable is 6, normally I would do 6 times 6 and get 36, a much bigger number. However, the transformation said to go backwards 4, take that output and reassign it. So everything's going to continue to get reassigned to a new x coordinate. And before you know it, you have a transformation. I'm going to go ahead and see if I can, trace it out for you. Oh, I don't want the line, I want the pencil. Here we go. And I want it thicker. So there's a transformation. Everything, all the output values got pulled to the right. So our x's, we went back 4 times, and then we took that output value and reassigned it. And then here's our original function. I hope that was helpful for you to visualize what was happening. You are going to now practice making your own transformation using Microsoft Mathematics. You're going to graph some points, and then you're going to show me how each point was transformed using arrows, different colors, somehow make it clear to me how everything is shifting. And you'll go ahead and you'll save that to your student drive and upload it to the Moodle assignment.